Kia ora and welcome to this video, our second in the series Agile Algebra. In this video, we're going to look at a problem involving the remainder theorem. So here it is. We've got a cubic equation, and we're told that if we divide this cubic by a quadratic, x squared minus 1, that we get a remainder of 2x plus 3. So it tests your understanding of how to divide polynomials and also how to apply the remainder theorem. Like always, give the problem a go before you look at the solution, which is on the other side of this intro vid. All the best. Okay, this question isn't nasty. You just need to understand how polynomial long division works. So we have a cubic, we're dividing by a quadratic, and so therefore we get a remainder that's either linear or less. Okay, so the degree of the remainder is always at most one less than the thing you're dividing by. Dividing by quadratic, we've got a linear remainder, so that makes sense. Although it is possible to get a constant remainder, that would just mean that the linear term is not there. So when we do the division here, we have our cubic, where a and b are just numbers. And we're dividing by x squared minus 1. Now when we do that, that's going to give us some quotient, which kind of represents how many times the quadratic goes into the cubic, plus a remainder, 2x plus 3, all divided by the thing that we're dividing by, x squared minus 1. So that's the setup of the division. Kind of like when you take 7 and divide by 3, you get how many times the 3 goes into 7, 2. 2 times 3 is 6, so we get a remainder of 1, and then divided by the thing that we're dividing by. So that's the same setup. Okay, with this, we don't actually need to know the quotient. We're trying to find a and b, but we don't need to find this q of x function. A clever thing to do here is to multiply both sides of the equation that we've got, which is true for all x, except, of course, x equals plus or minus 1. But if we multiply the whole thing through by x squared minus 1, we get some quotient, some function, which we don't know, multiplied by x squared minus 1 plus 2x plus 3. Now, to find a and b, we just need to realize that this equation is true for all values of x. The left-hand side's a cubic, the right-hand side is a cubic. And if we substitute in x equals 1, when we do that, the left-hand side becomes quite nice. It becomes 1 plus 3 lots of a plus b minus a plus 2. And when we sub in x equals 1 into the right-hand side, we get some quotient function evaluated at 1. Bit of a problem because we don't know the quotient function, but it's multiplied by 0 because subbing in x equals 1 into that bracket makes 0. And then subbing in 1 into the remainder gives us 5. So we end up with an equation that we can simplify. 1 plus 3a plus 3b plus b minus a plus 2 equals 5, or 4b plus 2a equals 2. And we do the same thing by subbing in x equals to minus 1, because that's another value that's going to make that quotient function disappear. So when we sub in minus 1 into the left-hand side, we get negative 1 plus 3 lots of a plus b minus b minus a. So be careful there because we're subbing in minus 1 into the x plus 2. And this is now going to equal 1 on the right-hand side when we sub a negative 1 into that remainder. Okay, and if we tidy this equation up, we get 4a plus 2b equals to 0, I believe. Just check that that's right. Yep. Okay, and then if we solve this equation, 4b plus 2a equals 2, with 4a plus 2b equals 0 simultaneously, we find that the answer to the problem is a is equal to negative 1/3 and b is equal to positive 2/3.